Hello and welcome to the ST stand at Embedded World 2017. Now, 12 months ago at this very same event, ST unveiled the STM32 Open Development Environment, and boy has it been a busy 12 months. Alessandro Malaberti, how has the product evolved over the last year?
Hi Chris, yes, in the last 12 months we had added a lot of new functions to the program. We have now 31 expansion boards that allow people to have more functionality in connectivity and sensing. We have introduced the function packs. Function packs are a predefined package of software that include functionalities that are usually found in IoT applications. And we have introduced modules. These are little boards that allow developers not only to create a prototype, but even to have a final device that can go in production.
So just imagine for 1 second, I know it might not be easy, I am developing an IoT application. How is this going to help me?
Well, let's suppose you are an IoT developer, like you said, and you want to create an application that sends data from the environment and send this data to a cloud. So the first thing you need is to create a sensor node. So how you do a sensor node with the STM32 Open Development Environment? You do it like this. You take a Nucleo board and you stack on top of it several sensor and connectivity board. In these cases, it's a Bluetooth Low Energy. Now, when you're finished, you want to create a real product. So to create a real product, you can use one of our module that is created. This is a module created by a third party called SensiEdge. And this module contains exactly the same components of this stack of boards. So it's clear that if you want to go to production, now you can put this in a real product. These boards can be bought online by several e-distributors. If you are a really, say, big company that want to go in high volume, then you can use this reference design from ST. It's called Sensor Tile, that include everything you can find here. So really you have now a sensor node that can be connected to the cloud.
Okay, well that's my next question. Once the data is there, how does it get to the cloud?
Oh, you have several ways to connect this sensor node data to the cloud. Either you have a device like this that is connected to the cloud by Wi-Fi. This is another example of module made by a third-party company. It's called CloudGem by a company called RushUp. Or you can create what we call a network of nodes that are connected through a gateway to the cloud, and you can see that we can send this data to cloud providers such as Microsoft, Amazon, or IBM. So this is how the data are connected, and the advantage is that when you have done this, you can see the result on a cloud server. And in this case, you can see temperature that vary on an Azure, Microsoft Azure cloud.
I mean, listen, the headline basically is it makes it a heck of a lot easier to create an IoT application.
Well, I think you're right. When you are an IoT developer, you don't want to create and spend time in how to assemble this hardware and software. So with STM32 Open Development Environment, now you can concentrate on your application, your secret sauce as an IoT developer, and don't spend time in creating all the baseline that you need to create your application. So at the end, ST, we think that we have all the devices to support IoT development, and now we have a great environment that allows you to create this application and an ecosystem of third-party partners that allow you not only to create a prototype, but even to create a final product. So I'm sure that IoT developers will appreciate and use this environment.
As always, it is a pleasure talking to you. Thanks, Alessandro.
Thank you.